In this video, I will introduce you to the software called R. R is extremely useful in research, not only for statistical computing, but also for a number of other tasks, making tables, making graphs, random sampling, and also just useful for doing regular mathematical operations. So it can be used like a calculator, but it's also extremely useful for a number of other reasons as well. So the first thing that I would suggest doing is, if you haven't already, please download and install the software for your computer. It is completely free. You can start by downloading R using the first link, download and install it, and then I would also suggest downloading and installing what's called RStudio Desktop, which is just a nice, user-friendly way to interact with the R software. It's optional to get RStudio, but I would recommend it. Once you've done that, then I would say move ahead with the rest of the video. So I would say pause and download and install if you haven't already done so. Once you've installed RStudio, this is what it should look like. In the upper left, you have the editor. I've already included a file. You can actually find this file on Brightspace in a new module that I set up that's called RStuff. And you can open it in RStudio and it'll look like what you see there. And these are the lines of code that we'll be running just to kind of get you started and get you familiar with some of the syntax and the different commands in R. In the lower left, you have the console. You can also just type code directly into the console, or if you run code that you've written in the editor, it will show up in the console as well. So you see an example here. I just did a quick math calculation to figure out how many minutes there are in a year. In the upper right, you have the environment. Nothing is there right now, but once you start storing objects in R, those objects will show up in the environment section. And in the lower right, it's just called the miscellaneous section. There are 5 different tabs. You see files, plots, packages, help, and viewer. Right now it's showing help. So if you look up information on a particular command, like the REP command you see there, REP stands for replicate. So that's basically, if I just searched for help on replicate, that's where you can find that. Also, if we make plots, they'll show up in that area of the RStudio window. All right, so in these slides, I have a bunch of lines of code that I've also included in the file that I showed here in the upper left. So what I would suggest doing is just go ahead and open that file in RStudio, and then I'll kind of walk you through how to run that code. I'm not going to walk you through every single line here, just because I think that would get extremely tedious. But basically, we have some math operations. We have some information on, or some examples on how to define objects, how to use math operations involving those objects, how to work with lists of numbers, which can be really useful when you want to start inputting data that you want to analyze. A little bit more on lists and taking subsets of those lists. Logical operations. So logical operations are things that involve true or false. And then using different commands, such as the sample command for random selection and random assignment that we talked about earlier in the semester. So I've just given a couple examples of how to do that. And other useful commands such as print, length, sum, mean, plot, and lines. So I'll show those briefly in RStudio in a moment. And finally, just something a little bit more advanced with an if-else statement. So now I'm going to exit out of the slides and head on over to RStudio, and I'll show you some commands there. So in the first line here, the first 4 lines, I should say, I basically just kind of gave a little note as to how to run lines of code. So just wanted to point out that you can use the number sign or like a hashtag symbol to write notes to yourself. So I've basically annotated the code with lots of different notes here in green that you can look at as you're going through this. So just know that that's an option. Anything to the right of the number sign or the hashtag symbol will not be treated as code. If you don't put that there and you still have a little note there and I run this code, it's going to come up with an error because it's not understanding what this is supposed to be. So we need to make sure we put that back. And so to run a line of code, if you're using a Mac, you're going to hit Command Return. If you're using Windows, you're going to use Control R. You can select and run many lines at once, or you can do them one at a time. If you want a reminder of what your keyboard shortcut is, you can just go to Code, Run Selected Lines, and it should show you right there. So again, for me, with a Mac, it's Command Return. And also just type or click on this drop down to run it as well. So 10 squared is 100. 10 times 10 is 100. Another way to write 10 squared. So you can go through all these different math operations, defining an object. Go ahead and run these line by line and just try to make some sense of the syntax. So the colon here, for example, is just going to do 1 through 24. It's going to print all the numbers, 1 through 24, whole numbers. We can use the command rep or replicate to do 4 through 6 twice. So 456, 456. Or if we do a slight variation on that, each equals 2 instead of just 2, it's going to do 4, 4, 5, 5, 6, 6 instead. So just the same thing, but in different order. If you ever want to find help on a particular R command, you just use question mark and the command, and it should show up down here in the help section. SEQ would be another example. Also keep in mind you can just type things directly into the console. So we could do question mark SEQ down here, and it will show up with the help on the sequence generation command SEQ. And it gives you some more information about the syntax for it. It usually at the very bottom will give some examples as well that you can copy and paste and use to kind of make sense of. So if I want to do a sequence of 0 through 100, counting by 5, just use this syntax here. So it's basically the first number, the last number, and what we're counting by. And so if we run that, it's 0, 5, 10, 15, etc., all the way through 100. All right, I didn't want to go through this line by line completely because it's just going to get tedious. But again, please just run this on your own, make some sense of it. Come into class with any questions. We'll get into some more interesting stuff, some more research-oriented stuff in class. I just wanted to give you a chance to familiarize with the environment and the software and the syntax and different commands. Sample is one that you'll already be somewhat familiar with. I showed it one day when we were talking about random selection, random assignment. So, if we wanted to come up with a study sample of 20 from 1,000 people in a population, if we had those people numbered 1 through 1,000, we can select 20 of them. If I just type in study sample here now that I've defined it, I can actually show the list of those 20 numbers that I selected randomly from 1 through 1,000. And then I can assign 10 to a control group, assign 10 to an experimental group, and I can just kind of print out all those numbers in order by using the sort command. And so what we see is basically here is our initial sample of 20, and the next line is the 10 that are in the control group and the 10 that are in the experimental group. Some other useful commands. So make sure I define what X is. So this is my list of just 6 different sort of random numbers. I can print it. I can print hello world. The length of x is going to be 6 because there are 6 items in that list. The sum of x is going to be whatever you get when you add up all the items in that list. The mean is when we take that sum, 73, and divide by the length. So 73 divided by 6 should give us 12.166 repeating. So I could do 73 divided by 6 manually and get the same answer. And I can plot. The main last thing I wanted to show you was what will happen if you plot something. So if I plot those numbers, not super interesting because I don't know what order they're in, but it's just like the first number is this, the second number is this, etc. And I used lines to kind of connect the dots. I just wanted to kind of show that if you do plot something, it's going to show up down here, and you can interact with it in different ways. You can zoom, you can open up a new window to zoom in on it. You can resize that to see it a bit better. You can export it and save it as an image or save it as a PDF. You can copy it to the clipboard and paste it somewhere else. So we'll get into some more stuff in class. Run these last couple lines, but this is a little bit more advanced. Basically an if-else statement using some of the logical stuff that I covered here. So go ahead and run this code, play around with it on your own as well, come up with some new code, again just by typing in the console, or you can open up a new R script and start again here and maybe do something a bit different, like, I don't know, just some math operations like 4 to the 10th power or something like that, and run it and play around, have fun. All right, thanks. I'll see you in class.